Good morning, children. Let us proceed on to miscellaneous problems of chapter 5. If f of x equals e power ax, then show that f of 0, del f of 0, del square f of 0 are in GP. GP tells me geometric progression. First of all, let us find out what is f of x, del f of x and del square f of x, and then we shall proceed. Given f of x is equal to e power ax, we need to find out del f of x. This delta, we remember the formula f of x plus h minus f of x. So delta of f of x equals, wherever x comes, I must put x plus h. E power ax, e power a into x plus h minus f of x. Just copy as it is. The next step, this can be split as a into x plus a into h minus e power ax. Plus symbol in the power tells us multiplying. So e power first term into e power second term. Plus in the power tells us multiplying. E power first term into e power second term minus e power ax. If I take e power ax as common, I am left with e power ah minus 1. E power ax is common. Here e power ah. Here nothing tells me 1. So this is the answer for del f of x. The next step, let us find out del square. Del square f of x. This tells me del of del f of x. That is del of. What is del f of x? E power ax into e power ah minus 1. When I apply del, I need to add h with x only. This is a constant term, no x at all, so I can keep it out. E power ah minus 1. This is free of del, keep it out because it is just a constant. I need to put del of e power ax. Now, what is del of e power ax? That is what we have done here, because e power ax is nothing but f of x. So, this answer I can just copy here. E power ah minus 1 into del of e power ax. We have the answer. E power ax into e power ah minus 1. Now these two are same terms, so we can multiply. E power ax into e power ah minus 1 the whole square. E power ah minus 1, e power ah minus 1. So e power ah minus 1 the whole square. This is del square f of x. Now we need to find out what are these three. So what is f of 0? E power a into 0. Wherever x comes, I am putting 0. E power 0 is 1. What is del of f of 0? E power a into 0 into e power ah minus 1. Wherever x comes alone, I put 0. E power 0 is 1. So we just get e power ah minus 1. Next I need to find out del square f of 0. E power a into, in the place of x I put 0. E power ah minus 1 the whole square. Again, e power 0 is 1. Ignore, only this remains. E power ah minus 1 the whole square. Now I want to show the three terms are in GP. Recall the formula. A, B, C are in GP. What is the condition? B square equal to AC. Or I can say B by A equal to C by B. Whichever is convenient. Either B square equal to AC, or I can say second term by first term equal to third term by second term. GP is geometric progression which has a constant ratio. What is here? I have 1 e power AH minus 1 e power AH minus 1 the whole square. This is A, this is B, this is C. So treating this as A, B and C. B by A, e power AH minus 1 by 1 is e power AH minus 1 the whole square by e power AH minus 1. As I check, both are equal. So we will say f of 0 del of f of 0 del square of f of 0 are in GP with common ratio. What do you mean by common ratio? It is second term by first term. See, 1, whatever comes the whole square. So the common ratio is e power AH minus 1. Whatever I get second term by first term or third term by second term, that answer I call common ratio. So we have shown f of 0, del f of 0, del square f of 0 form a GP. Let us quickly rough through the problem. Given f of x is e power ax. The question is about del and del square. Del f of x, we remember the formula f of x plus h minus f of x. Wherever x comes, put x plus h. Multiply, split the terms, take common term out and we get del f of x. Del square tells me del of del f of x. So what is del f of x? From here we copy. Here there is no x at all, keep it out. Del is applied only for terms with x. Delta of e power ax already we derived, so we just copy. From these two, I get both are same, so I can multiply. Once I know f of x, delta f of x, delta square f of x. Let us substitute wherever x comes 0. F of 0, delta of f of 0, delta square of f of 0. The moment I see, I can immediately declare they are in GP because it is of the form 1 a square. So I can immediately say it is GP. If you are not able to conclude, you can very well use this formula. So what do you mean by geometric progression? Second term by first term equals third term by second term. As I substitute also, I get e power AH minus 1 cancels with a square. Both are equal. So we are able to declare the given three terms are in GP. Question number 2. Prove that 1 plus delta into 1 minus nebula equals 1. All the problems have E delta nebula. So let us recall the relation between E delta and nebula. Nebula equals E minus 1 by E, whereas delta equals E minus 1. This E minus 1 by E I can rewrite as 1 minus E inverse. First subdivision, let us start with LHS, which is 1 plus delta into 1 minus nebula. 1 plus delta, I can write E from the formula. 1 minus, what is nebula from here? E minus 1 by E. That is E into. Taking LCM, that is E, cross multiply E. There is minus symbol, take it in. Minus E, minus of minus is plus 1. Minus E plus 1. Cancelling E and E. E minus E also cancels. We just get 1, which is nothing but RHS. Second subdivision, we want to show delta into nabla. This is LHS. What is delta from here? E minus 1. What is nebula from here? E minus 1 by E. Because I want delta minus nebula, let us multiply and simplify. As we multiply, it is E minus 1 into E by E minus 1 by E. As I multiply E into 1, 1 into 1, minus E into 1 by E, minus into minus plus 1 by E. As we cancel, we get E minus 1 as it is because I want delta. Look at the final answer. I want RHS to be delta minus nebula. So let us reverse the steps. What is delta actually? I want E minus 1. What is nebula actually? E minus 1 by E. So to bring this result, let me take minus symbol out. I am left with 1. Minus symbol from plus is minus 1 by E. The next step, take LCM, E minus 1 by E. I can write this as delta and this as nebula, and that gives me the RHS. So these are the problems where you start from LHS. As you derive 2 or 3 steps, once you are getting confused, just reverse the steps from RHS. I want RHS delta minus nebula. What is delta I have written? What is nebula I have written? Just simplify. From back you write 2 steps. From the front you write 2 steps. Naturally, they coincide. So here E minus 1 into E minus 1 by E. Simplifying, I get 1 minus 1 by E. E into 1 minus 1 into 1. E into minus 1 by E minus 1 into minus 1 by E. I want minus symbol. So delta term write as it is. Take minus from these two. As I take LCM, it reduces to nebula. So delta minus nebula, RHS is achieved. Second method for the second subdivision using f of x plus h minus f of x for delta and f of x minus f of x minus h for nebula. As we start with LHS, it is delta into nebula. Delta of, what is nebula from here? F of x minus f of x minus h. Nebula meaning f of x minus f of x minus h. As I multiply, delta of f of x minus delta of f of x minus h. What is delta meaning? F of x plus h minus f of x. Minus symbol. What is delta of f of x minus h meaning? First time add h, second time write as it is. Here it is x minus h. First time with x minus h I add h. Second time write as it is. So delta meaning first time add h, second time write as it is minus. As I simplify, it is f of x plus h minus f of x minus h and h gets cancelled. I get f of x minus f of x minus h. X plus h minus f of x is nothing but delta. F of x minus f of x minus h is nothing but nebula. So this is another method without using E. I can directly use f of x plus h minus f of x for delta, f of x minus f of x minus h for nebula, and arrive at the RHS. We proceed on to third subdivision. LHS is E into nebula. What is nebula actually? I can write from here or from here, whichever is convenient. E minus 1 by E. Cancelling E and E, I just get E minus 1, and E minus 1 is nothing but delta, and that is the RHS. To show this result, LHS, I have nebula into E. What is nebula? Nebula is nothing but E minus 1 by E into E. Again, we cancel E and E. We just get E minus 1, which is nothing but delta, and that is the RHS. So, whether I multiply E into nebula or nebula into E, my answer is delta only. Second method for third subdivision, E into nebula equals delta. Let us recall all the three formula. Delta equals f of x plus h minus f of x. Nebula equals f of x minus f of x minus h. E of f of x is nothing but f of x plus h. As I start with LHS, it is E of nebula. What is nebula from our formula? F of x minus f of x minus h. As I multiply E of f of x minus E of f of x minus h. What is the meaning of E? It's a shifting operator, add h. E tells us add h. So E of f of x tells me f of x plus h. E of f of x minus h tells me f of whatever is there, add h. F of x tells me f of x plus h. F of x minus h tells me f of x minus h plus h whenever I operate with E. The next step, f of x plus h minus, here minus h plus h cancels, I just get f of x. What is f of x plus h minus f of x? It is nothing but delta. So we started with LHS and arrived at RHS. Question number 4. Find the missing figures in the given table. For y, 1, 2, 3, 4 values are given. If 4 values of y are given, let us assume the polynomial to be of degree 3. When the polynomial is of degree 3, fourth order differences are 0. Or we say del power 4 of y naught 0. Instead of del, we remember, we write e minus 1 the whole power 4 y naught equal to 0. How to expand e minus 1 power 4? We remember e power 4, e power 3, e power 2, e power 1 and finally 1. Minus symbol comes, so alternatively positive, negative. The whole thing into y naught equal to 0. How to put the coefficients? We refer to Pascal's triangle. How do we write it? 1, 1, 1. Keep adding and write it. All the time in the two corners we put 1. 1 plus 2, 3. 2 plus 1, 3 and 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4 and 1. So using Pascal's triangle, our question is having the power 4. So we use these values. 1, 4, 6, 4, 1 are the coefficients to be put here. 1, 4, 6, 4, 1. It's already there. So this is the expansion. What do you mean by e power 4 of y naught? It will become y4 minus 4 e power 3 of y naught, y3, e power 2 of y naught, y2, and 4 e of y naught, y1 plus 1 into y naught equal to 0. The same idea I can say del power 4 of y1 also 0. So this is, I can use y0, y1, y2, anything when the polynomial is of degree 3. I write delta power 4 of yk. So I can put y0 because I want two values. Write one more equation. Instead of y0, now I use y1. As I substitute, it is e power 4 minus 4e cube plus 6e square minus 4e plus 1 into y1 equal to 0. As I apply, e power 4 of y1 is 4 plus 1, 5 to remember, y power 5 minus 4 e cube of y1, y4, e square of y1, y3, e of y1, y2 plus 1 into y1, y1 equal to 0. As I substitute the values from the table, look at the table, the values y0, y1, y2, y3, y4, y5. As I substitute in equation number 1 and 2. y4, I do not know. 4 into y3, 18. 6 into y2, I do not know. Write as it is. Minus 4 into y1, 11 plus y0, 7 equal to 0. Simplifying this, y4 minus 72 plus 6y2 minus 44 plus 7 equal to 0. y4 plus 6y2 equals minus 72 goes to the right plus 44 minus 7, or use your calculator and simplify as 109. Second equation, y5 32 minus 4 y4 plus 6 y3 is 18 minus 4 y2 plus y1 is 11 equal to 0. As I simplify, minus 4 y4 minus 4 y2 equals minus 32 minus 108 minus 11. Minus 4 y4 minus 4 y2 equals, we get minus 151. As we simplify these two, this equation let me call 3. So third equation I multiply by 4. 4y4, 24y2, 4 into 109. As we add the two, these two gets cancelled. 20y2 equals 285, and as we divide, we get y2 equals 14.25. Substitute y2 value in equation number 3. y4 plus 6 into 14.25 equals 109, or y4 plus 85.5 equals 109. Bringing this to the other side, 109 minus 85.5 gives us 23.5. So we have arrived at the two values. y2 14.25 and y4 is 23.5. Question number 8, given u0, u1, u2, u4. We need to show that u3 is 465. u0, u1, u2, u4. So we can create the table, say x and u. X values are 0, 1, 2, 3 is here, 4. 0, 1, 2, 3, 4. U0, change it as 579, 556, 520. This is missing 385. So my question is to find U3. Let us remember, since 4 values are given like the previous problem, I can say the polynomial is of degree 3. As I write del power 4 of y0 0. But in this problem, we do not have y0. Instead, u0 is there. So the same formula like the previous problem, but do not use y0. Rather, it is only u0. As I expand, wherever y comes, let us write down u0. So the equation will now become u4 y3, I just write u3, y2 is u2, y1 is u1, and y0 I will write u0. So the expansion from this Pascal's triangle we have written for e minus 1 the whole power 4. As we substitute the values, u4 is 385. Minus 4 u3 is not known, plus 6 into u2 520 minus 4 u1 556 plus 579 equal to 0. As we simplify the terms, minus 4 u3 plus 385, 6 into 520 minus 4 into 556 plus 579, 0. Bring the numbers to the right side and simplify. We get minus 1860. U3 equals minus 1860 divided by minus 4, or we get 465, and that is the question.